I'm going to try to use this if I can. Did I go too fast? I think I'll just use the mouse if I can figure it out. It's easier that way. These things are really complex to use. So I'm the founder of Security Compass. Our company pretty much focuses on application security. We do a lot of source code review, pen testing, threat modeling, and training. And we are primarily the partners with SANS to develop a lot of their J2E security courses and .NET courses and teach as well. So why are we talking about threat modeling? Well, we've been doing threat modeling for nearly 3 years, and we started with, I was involved long back in my background. I used to work for Foundstone, and we did a lot of consulting for a software vendor based in Seattle. And it got a lot of exposure to their models. We originally, when Security Compass started as well, we used to do a lot of threat modeling using the Microsoft approach, and as we've gone through doing threat modeling over a period of time, we realized that there might be some additional steps or slightly different approaches that we can take, and what we are going to try and do today is talk a little bit about both the approaches and looking more deeply into these approaches as well. So that's pretty much about me and what we're going to talk about. With that, I'll leave it over to Krish.
Good afternoon, my name is Krish Raja, and I am a security consultant. And security assessments for many different clients. The assessments typically involve anything from penetration testing to source code review. Of course, the threat modeling and threat analysis, the typical Microsoft model, the model that we've adapted that's very similar to the Microsoft model in terms of threat. We'll talk more about that traditional threat modeling, a bit of a different. So here's the agenda today. So we'll talk about the traditional threat modeling, what occurs and what the process is, some of the outputs that come out of performing threat modeling, benefits of this approach. We'll then take a look at a particular case study for a company called False Secure Bank, who has a web application. We'll go into the details of that application a little bit further. And then we'll talk about the different spin on threat modeling that we have, which is something that we call code level threat analysis. We'll talk about what that entails, how it differs from a traditional threat model, what the process is, what the inputs are. And we'll look at some of the benefits and drawbacks in comparing the two approaches to threat modeling. So I guess first, the first question really is, what is threat modeling that we know of right now, traditional threat modeling? Has anyone performed any threat modeling before, or is anyone familiar with the concept of threat modeling?
Sure.
Would you like to give us your ideas of this, and what you think it entails at a high level, I suppose?
Sure. There's the traditional Snyder model.
Yeah.
Former Aztec users got hired by Microsoft, wrote the threat model for a lot of blogging with Microsoft about it. Basically, looking at assets of your application, trying to figure out entry points in those assets, maybe some privilege levels that you might, roles that might get you there.
Yes.
And just basically putting on the black hat, thinking like an attacker.
Absolutely.
Maybe looking at some attack patterns. Howard mentioned this a few years ago in a talk. Canonical, 13 or 17 different attack patterns. We've got the stride model that can break things down into. So there's a lot of different,
Yes.
interpretations of what threat modeling means. But at the core, it's kind of thinking like an attacker.
Very good, yeah. That's probably the biggest point right there is adopting the attacker's mindset when you're looking at an application.
And that is exactly, I guess I would go back to the very basic of threat modeling is pretty much putting on an attacker's hat and looking at an application from an architecture level and an application at the detail level itself, at the application level itself, and trying to identify what the major attack vectors are, what might be implications inside that application. He's documenting all the major attack vectors. The end deliverable, if you will, is to try and have a list of attacks that could potentially be possible with an application. If it's an online banking application or whether it is a client server application, it doesn't really matter. It's what are the possible attack vectors and what are the possible attack vectors and what are the possible mitigation techniques. Is there a vector or? Okay. And what we're trying to derive at the end of the day, as we said, there are the major threats, what exists inside an application, the attack vectors inside the application, possible mitigation techniques inside the application that we will be looking at. Here we have a simple pictographic representation of the Microsoft model or the traditional model that has been provided. I guess some of that. There are 5 major steps. There is security objectives, identifying the threats and identifying vulnerabilities. What we have tried to do is make it into a more serial approach, if you will, and try to break down the major steps. So here are the major steps, the way we try to do it, which is pretty much the same as the Microsoft model. This is the traditional model, the way we are trying to refer to it in this presentation. Is gathering information. So what that entails is basically sitting down with the business analyst, sitting down with the architect, sitting down with the lead developers, and trying to gather the information about the application, understanding the application to as deep a knowledge as you can, possibly reading user documentation and anything else that we all know every application has out there today. And then also the other aspect of this, and an important aspect of this, is to try and look at all the 3 major areas from a developer's point of view, from a business analyst's point of view, and an architect's point of view. What do they perceive as the most important threat to their application? And it's surprising how you find that all 3 of them might have completely different threat vectors in their mind that would keep them awake at night. So it's trying to get information about the application. And then the next step is trying to decompose the application into maybe various roles inside the application, the various components that exist: web server, database server, app server, administrative user, regular user, help desk user, that kind of stuff. So that later on, as we are developing the use cases, and not abuse cases, but use cases, we actually will be able to use these components inside it and identify the various data classifications inside it and say, okay, between client and server, this type of data is flowing and this type of attack is possible, and then is there a mitigation technique that is implemented? And the idea is to do this theoretically with the architects, and then you go and validate that through either a point test or source code review. And it is many times you find that people might think they have implemented structs with validator config file has everything, but so they are okay. But when we go and review that, we find accidentally they just got a black file. So there is the assumption, there is the documentation part where okay, this is what should be there in the application. The next step is validation of that as well. And then we also have to develop data flow diagrams. Now this, the reason we like data flow diagrams is, from the picture itself, you can understand how the entire data is flowing inside the application. And you want to probably go as deep a level as you want. We try to do it at level 0, which is very high level, then break it down to maybe up to level 2, where you can see the process level interaction from process 1 to process 2. You can also draw test boundaries, do the input location and output location, so that at the end of the day, when you're actually going into the app vector list, you can map it out and see, okay, is this the reason why you're not doing input validation at this component level, at a much deeper level, because it might already be taking place at an earlier level along those lines. The next step is, what is the actual output of the threat model? Now, if you take a typical use case where an end user is browsing to an application and he's logging into the application, what is the attack vector? Well, there could be multiple attack vectors. User may be using a shared machine, like library machine, or from the airport. He's using a machine, and there are possible attack vectors because the information is cached, and there might be attack vectors of input validation again not taking place. And the idea is discussing what are the attack vectors, what are the threats, and then what are the mitigation techniques for each of those. And then you go and validate those mitigation inside a threat model. This is the typical threat model and the type of output. In this scenario, you can bring it in a hierarchy model. You can even do a simple list, whatever. The idea is, again, it could be a tabular format, but there is some way of knowing where the attack is possible, what is the possible mitigation, and if it is implemented or not.
So I think we can see, and we've become familiar with some of the benefits of doing the traditional threat model. It gives us an understanding of the application, a nice snapshot of how the components make up the application, and what some of the threats are that exist to the application right now. So maybe we can take a little more of a concrete view and try and apply it to a particular case study. So that's kind of what I'm going to speak to right now is something we call false secure bank, and just think of it as your typical web banking application, for example. So, and suppose we've been giving this web application that has been running for X number of years, let's say, and we've been asked by False Secure Bank as security consultants to assess the security posture of this particular application. So I guess one of the things we could do would be a threat model.
Yes, we could definitely do a threat model for this application. I guess what would be the various stages, that would be involved is information gathering stage, right? So do you have any architecture diagrams, or do you have any additional information about this application itself?
Okay, well, let's suppose that the architecture is laid out as a typical multi-tiered architecture. So something that, in this case, is specific to False Secure Bank, for example, but it's something that can probably apply to many different applications that any of you might have seen, or anyone has assessed before, where you've got your client logging in through an internet browser, the requests go to a web server, those requests get forwarded towards the application servers, the second demilitarized zone. That's where some business logic perhaps lies and does some of its logic and forwards transactions to the database to make it to the database. So let's suppose that this sort of your cookie cutter custom popular kind of framework that we have in our architecture here is what is used for false security.
Okay. So would you like me to do a threat model for this, the traditional threat model for this then?
Yeah, I think so.
Okay, so
Some of the processes.
let's go to our typical threat model process and spend a couple of minutes. What would be the stages? Again, this is the same diagram you saw earlier. What would be the stages inside this application is gathering information? Now we have a rough idea of, okay, there are three-tier architecture. You have the web server, you have the application server, and you have the database server. So those are your components. You have roles inside this. So you have a user who will connect to the application, try to transfer money from one location to the other. Now, some of the questions that you will be trying to gather is this an application that is a typical traditional web application from a banking point of view? Is it going to allow me only to read what is the balance, what are the transactions, or is it going to also allow me to write into the application? Who else has access to this application? How is the data stored inside the database? Is there PII data? That kind of information is typically gathered from sitting in initial information gathering meetings. Out of that, we would try to again break down the various components. Like let's say you could have your web server. You already know the major components there. We have also the user roles, and then we are going to try and draw data flow diagrams. Go deeper at that level and try to go to the process level. Okay, where is the authentication module actually taking place? Are you actually authenticating with the LDAP server, or is it sitting at the database level? Where are the process transactions taking place from one process to the other? That level of detail is what you want to come up with at the DFT level. And what is the interaction at that DFT level you need to actually document? Where are the trust boundaries? And what is the trust boundary? Basically, let's say that anything that crosses this trust boundary has already gone through some of the application authorization project. And then you would try to identify all the risks that are associated with the application and then try to develop use cases. So what are the use cases? We would say, okay, a typical user that logs in into the application and transfers money to pay his bill. That's a typical use case. Now, in most cases, you can develop use cases for any kind of banking application, could be hundreds of use cases. But what you're trying to do is you have limited time and you're trying to focus your use cases to the most important ones. So you try to narrow it down to 10, 15 use cases, and you don't go all the way into every single use case. Okay. After you have gone through the use case development, where you're actually part of it, you're going to also say, component A to component B, like the browser to the web server is communicating, and it is, so what are the major threats in relation to that? And what are the mitigations in that? So the threats are someone could do man-in-the-middle attacks, someone could sniff the network and actually do replay attacks. Okay, what are the mitigations? Okay, have they implemented SSL? Yes, they've implemented SSL, so that threat is mitigated. So you're trying to document the traditional threats that are there, and that is how you could come up with the attack trees, all the attack pattern, attacks that could take place inside the application, as well as the mitigations that could take place inside the application, or that should be there inside an application. So that's what we would go about doing inside this false secure application.
Okay, so I think we can see that it does still provide some benefit, although I think we mentioned that usually the best place or the best area within the SDLC to perform threat modeling for an application would be during the design phase. In an ideal world, that's probably where we would want to do it, so that while we're actually building this application, we have some of the threats identified. Would you agree with that?
Yeah, I would say that. Ideally, in an ideal world, we would be called, or the architect would have this knowledge to develop the threat model at the design stage before the application goes into production itself, even to the developers, and they have already figured out all the major attack vectors inside the possible application, and the design would never change, of course.
Right.
That would be one of the key factors as well.
Okay, so realistically, we're usually process or some kind of internal applications that just their internal employees access, that falls under the same architecture, so the same multi-tiered architecture that we saw in that diagram. Would we be able to threat model this? Would there be a tangible difference in the threat model for this?
I guess I wouldn't want to threat model this again, because realistically, if there are the same components, same kind of transactions taking place from one layer to the next layer, it would be wasted money essentially if I was the client, that the same exact output, I'm not going to pay for the same exact output, and there is no real return value unless I'm going to write a lot of different things and have a complete different architecture. But typically a bank is not going to do that. If they have an existing architecture, they're going to try to reuse a lot of components and bring it right into the existing application flow itself.
Okay, so I think the question is, so let's suppose that we assessed False Secure Bank last year, and they want us to assess another application on the same architecture this year. So is there a way to do a deeper analysis if we were to perform threat modeling again? Let's say they were so happy with the initial threat model for the first application, so that now they want us to do another one for this new application.
I don't know. I mean, I would suggest that they don't hire us, because I don't think that there is anything else that can be done. Do you?
I think maybe there is. Here's a sort of a radical thought. So we can get into something that's called code level threat analysis. And it's similar in some ways to the traditional threat model, but it differs in that we're now trying to dig into the actual code base and elicit the threats that are involved in how the application has actually been implemented. So code level threat analysis focuses on the actual developmental framework and the developmental design patterns and code base of this application. And it consists of these 6 basic stages, some of which are very similar. Certainly the first step in terms of information gathering is pretty much identical to the traditional model. We want to sit down with a group of individuals from our client space that know the application very well. These could be business analysts and architects, and we gain as much information from them as to how this application works. And based on the outputs from that information gathering session, we can probably derive some use cases. So that's the second step, which is again fairly similar, although maybe a little out of order from the traditional. Step number 3 is probably where we really differ, because this is where we start to look at the actual source code. So source code is a requirement to do code level threat analysis, as you probably could make that assumption from the title, but that's where it differs. We'll take the source code that's involved specifically with the use cases that we've looked at, not all of it, but just the ones involved with the use cases, and we'll do some analysis on that source code. The output of that comes from something we call a mitigation map in step 4, and we'll go into each of these stages in more detail. The mitigation map can be represented in something we call mitigation flow diagrams to basically show you whether there are security features being implemented in the code base that mitigate against some of the common application security threats. And finally, based on all this output that we have, we can perhaps derive a list of recommendations. So we'll go through first. The first step again is almost identical to the traditional threat model, is information gathering. So we want to gain a thorough understanding from individuals, from the clients. Basically, we want to know, what is the application? What does it do? What are its business goals? Who uses it? Are there different levels of users? What are their access rights? It's the kind of thing we'll be getting at these kinds of questions. And of course, the data is pertinent to the application. So what kinds of data does it store? Is it personally identifiable information that it's storing? What kind of transactions does it perform? Are these transactions secured in any way? These are kind of the information gathering that we do in the process. And we do this with individuals such as architects who can tell us how the application is componentized. Business analysts will give us a better idea of the use cases involved. And the lead developers will give us some hints into the actual code implementation and what kind of code patterns, maybe design frameworks that have been used in implementing this application. So from the information gathering process, we'll probably come up with a level of use cases. So in an ideal world, again, we'd probably be able to come up with as many different use cases as we can, but we're all working under a schedule, of course. So we'd probably say something typically of about 10 to 20 use cases in mind. And we want to keep security in mind when we derive these use cases. So for instance, if we had one use case where a user logs in or maybe not even necessarily logs in, the user basically just accesses a help page or a contact us page or about us page. Well, really that's just static information that's being browsed, and there's nothing really pertinent in terms of the data that's being displayed or any data that's being sent from the client that is at any high level of risk. So those are not really the use cases we would focus on, right? We would, for false secure bank, for example, think about things like users logging in or transferring money between accounts or adding a page or any other use cases you could think of. So this is where the approach can differ quite a bit. We get into actual source code analysis. And what we want to do is, based on the list of use cases that we have, maybe 10, maybe 20, somewhere in between, now that we have access to the source code, which is a requirement, we want to be able to look at the classes and objects that are involved in that particular use case. And of course, you'll probably have to do some checkbacks with the client staff to make sure that you're on the right path. These are the code fragments that are being accessed, the classes that are being called, for example, with that particular use case. But we can get an idea of the objects that are involved in the particular use case and the call flow that goes between them, and even some of the data that's being passed between the objects. And also what we can end up with after we study this for a few use cases is we might tend to see either the design framework that's involved or some kind of developmental pattern that is involved between use cases. They all involve these basic kinds of classes the use cases do, for example.
So would you say that if we had after looking at code inside Vault Secure, if there was a transaction that is taking place over a period of time, we figure out that you have a request coming in, it goes through a validator command, it checks for what type of return is there, and then it goes to XML transmitter, and then it transmits to the business object, which creates a transaction, then goes to the database object, and then goes all the way back. So is this something that you would say is the common pattern? Basically, you have an input, you do input validation of some kind, you actually then send it to an XML transmitter which converts it into XML in some way, sends it to the business object, does some business logic transaction, and then sends it to the database?
Absolutely. So what we have here basically is a sequence diagram, but it's not necessarily what we'd say is one of the outputs or artifacts that we would deliver to the client. We'd say this is all part of our thinking process and our discovery process from the information gathering and from the source code analysis. We've discovered that a lot of these use cases in the code base follow this basic framework. For example, requests go into a servlet calls a command to do some validation. Data is passed between the command and the business object through an XML transmitter. So this is the basic pattern that we see. A business object creates a transaction and calls a data service. So this is something that we can discover, hopefully, through doing some of the source code analysis. The first thing we discover is a pattern that's involved in the code base.
So do I need to do this pattern for all the 10, 20 use cases, or what should I actually do?
The pattern you'd probably find just by analyzing a few use cases, and you would just map it out. So think of this as kind of your thoughts on paper. Now that I've analyzed 3 or 4 use cases, I've discovered this is the pattern that the code base follows. So I wouldn't do this for every single use case. What I could do for every single use case, though, is actually just one step too far, is this. So based on the pattern that we saw in the previous slide, for a particular use case such as transferring money between accounts, we'll say, okay, well, the display servlet involved is transfer money servlet. The XML transmitter involved was transfer money XML, and so on and so forth. So this is the specific implementation of the pattern in the code base. And this gives us an idea of what specific classes are involved and some of the methods that are involved. So the transfer money command has a validate inputs method.
So we would develop this for all the 10, 20 use cases, and we would, again, this would closely map out to the individual sequence flow diagram itself, if you will. There is an input coming in, there is validation taking place, it goes through a XML transform of some kind, it goes through business logic, and then it goes to the database in some way or form.
Yes.
That's the overall idea that we're coming up with these use cases.
Right, right.
Okay, so what would we do with this use case?
So from this, we can now start the next step, which is what we call a mitigation map. So based on, now that we have all of our code fragments or code classes mapped out for a particular use case, we can now study these 5 or 6 or 7 classes for this use case and try to analyze what kind of secure coding practices are involved in this particular pieces of code. So these practices, of course, would stem from standard application security domains. So we saw, for example, there was a command class, what is common between this design pattern, and it was doing input validation, for example. We would also look to see if there is some kind of authorization check somewhere in the code base or authentication done in the code base for this particular use case. And there's other application security domains, of course, as well. Does anyone have any other ideas or categories for application security? You can just name them. For anything, just typical everyday application security domains.
Well, you mean you have things like session management?
Yes, exactly.
That's a big one.
Right.
When you're talking about looking at code, I was actually going to ask you, like, how do you factor this into a regular security code view where you look for things like bad API calls or just stupid comments in source code that say, like, fix, broken, or hack in the comments?
Yeah, so that's
just become part of that.
That's a good idea. So now we get into the sort of the question of the differences between traditional source code review and the source code analysis. So in a source code review, you're pretty much looking at a percentage of the code base, and you're trying to find basic vulnerabilities, right? The approach is similar, but not exactly the same here, where we're looking at the code base and we're trying to see what is being employed, and that's what we're trying to map out. What is it doing right now in terms of security in terms of mitigating against certain risks? Are there areas of these application security domains that are being performed in the code base? So for example, we could break down input validation, being such a broad subject, break it down even further to see, are malicious characters being checked? Is there HTML encoding being done? And so on and so forth.
And the point to note here is that the code analysis is being done from a higher, with the objective in mind of understanding the code and the layout of the code, and it's very different from doing source code review. And the idea is that the output of this will help you narrow the areas of where you want to focus on doing source code review, to actually look for things like what you mentioned, like bad API calls, or interesting comments like, here's the username and password you should use to connect to a database, things like that.
Another question.
I'm sorry, I don't totally get that. So, how is doing, sort of an architectural analysis, looking, using the code as a guide, going to steer you to, say, a runtime.exec call in some random class?
If you wait for one more step that comes after this, it will answer your question exactly, and we'll go to that, and that's the next step that we are going to talk about. So hopefully that step will answer your question. If not, we'll come back to your question.
So with the mitigation map, what you would do is you would outline for each row basically representing an application security category, and each column basically would map for your use case either the patterns that are involved that we know of. So there's a display servlet that's involved in the use case, there's a command and XML transmitter. And what we would do is we would map out where a lot of these categories or mitigations for these categories are taking place at which layer. So it gives us an idea of where certain features are being employed in the code base, for example.
So for something like our fault secure bank, we would see where are things like performance logging taking place, or where is authorization taking place, or exception handling taking place. Again, from an architecture point of view, and we'll try to map it out at the individual object level, and we'll say, okay, we are seeing exception handling taking place in this servlet, in this command, in XML transmitter, and data service itself. Okay, the idea of this entire process is that I'm going to do a quick snapshot review from an architecture level as well as go to the code level to have some kind of an output that would help me do a much more detailed code review.
Right, so it's not quite as detailed as an actual code review, but it's more detailed than what we get out of a traditional threat model, for example. It's sort of an in-between here.
So the next step is this mitigation flow diagram. What is this mitigation flow diagram?
So sometimes we know that a picture can be worth 1,000 words, for example. So a lot of people don't like to see things in a tabular format. Things make a lot more sense to them if they're represented in a diagram. So this is kind of taking your mitigation map and representing it in a diagram. You can have your objects in line from the request all the way to the back end, and you can color code and label where features are being employed. So for example, a level of authentication is being done in the transfer money command, exception handling is being done in the transfer money business object. So the security features that we've identified are being labeled and color coded based on the color code that whichever suits you in these mitigation flow diagrams. So what you can do with them is you can perform what we would say is a gap analysis from either the mitigation map or more frequently from the mitigation flow diagrams. You can look at the diagrams and you can try to identify if there are any inherent risks in the applications, or there are areas where some of these secure coding practices or categories that you've identified aren't necessarily being employed in certain classes along in the use case, for example.
Okay, so again, going back to our case study of fault secure bank, we would typically, for the individual use case, if we had to pictographically represent it, we would kind of say, okay, here is the end user, there is the database, we are coming to the app server and then transactions that are taking place, we would actually say, okay, error logging is, or performance logging is taking place in this blue representation, or exception handling is taking place in this gray representation. So we can kind of see that error handling is taking place here, here, it's not taking place here, and so on. And we can figure out where it is not taking place, and we probably need to spend time on that.
Right.
Would that be part of the gap analysis?
Exactly. So we can sort of look at what we've got here in a diagram, and we can say, for example, we've got some XML processing being involved. Data is being transported into XML format and being shipped somewhere. So we notice that Transfer Money XML, which is dealing with the XML data, is doing some performance logging. But you might want to add some more security features, for example, in terms of when you're transmitting it in XML, when you're transforming the data into an XML format, you might want to do some kind of XML validation as well, for example.
Okay, so what's the output of this? We have this diagram, but what do we tell the clients after this?
So what we would do is, well, after the mitigation flow diagrams, based on the output of the diagrams and based on the output from the mitigation map, we can try to come up with some recommendations for them based on saying, this is a snapshot of what's going on in your code base, the patterns that we see in your code base on where these security features are being implemented. Here's maybe some inconsistencies that we see. We can derive these recommendations from, for example, empty rows in a mitigation map. If system audit trail hasn't been filled in for anything, well, maybe based on what we see, there is no system audit trail being done, and we confirm this with the client, for example. For example, we see that there are some cases of exception handling being done, but is this something that's being done consistently in the code? It's probably something that we'd want to do throughout the code base, for example. And we could also focus, again, on empty cells, empty rows in the mitigation map.
So would it be fair to say that if we are looking at the traditional model, we developed the use cases, we had an output of list of threats and countermeasures, and that was focused primarily towards architects and security professionals, whereas this seems like if you're going to this level of detail, someone who is a developer or a lead developer would have more interest in something like this?
I think so. I think it speaks more to the developers themselves. There's something more concrete for them to see. Even if someone, for example, a new developer came on to the staff, this gives them a great background to see how security is being implemented in their application for these specific use cases, where they could go to look in the code base to see where certain features are being employed, or when they're developing code themselves, where they should, according to these patterns, be implementing some of these security features.
So would it be fair to say that every time I'm doing exception handling, or I'm trying to do some kind of a process in a particular place, say transfer money, I need to do these particular steps, always would be something as a developer that I should keep an eye out and try to reuse that piece of code?
Yes, so that's another good point, or a good question that you're raising there, is that it can also give an idea of, again, back to the idea of patterns, where code can be reused or where it is being reused in terms of these security features specifically, and you can implement your code as a developer based on these patterns.
So what is the actual benefit of doing code review based threat analysis, or code level threat analysis, as opposed to our traditional threat model that we have been seeing so far?
Okay, well, first of all, I think the first benefit that we see is that we get some documentation, and a lot of times documentation is something that's unfortunately hard to come by in a lot of software systems. You ask them for some documentation, they probably don't have any. Unfortunately, that's just the reality. But now you're getting some real documentation of the security features that are existing in certain code bases, in the code base, in certain classes of the code base. And again, as we just mentioned a few minutes earlier, it does speak specifically to developers themselves rather than just at a higher level in the architectural space, for example. Some other benefits is that now we have a living, breathing sort of document and as the code base is extended, this document can also be extended. It can be extended by developers or by designers or architects. When a new feature is added to the code base and that requires new classes, you can extend these outputs of this code level thread analysis to also cover those new use cases or cover those new features that you've added.
So for that credit card module, if we were adding that into our fault secure bank, then we would go back and do something like this to make sure that the use case finds all the major attack vectors and makes sure it reuses these components, and that would be one of the major advantages of this code level threat analysis, would you say not?
Definitely. So when a new feature is added, you can easily extend your documentation that you have to cover and find out what security features are being implemented with this new feature.
I think there are some problems with this as well. Obviously, it's going to take much longer to do code level threat analysis as opposed to traditional threat analysis, and it's always difficult to get access to code, so that's going to be another issue. We'll need to find someone who is not only able to do threat analysis but also be able to read and understand code and understand the object communication, and if we are lucky, we'll often get spaghetti code,
Right.
That's very common.
Yes. So by no means at all is this model perfect, or is it the ideal solution. There are definitely drawbacks. Of course, the first thing that stands out is source code is required. We're not going to be able to build these mitigation maps or these mitigation flow diagrams without the source code, and we need to have level of understanding of how source code works. And it's definitely more time consuming. Now that we have source code, it's something else to analyze, and it's a major step. So we have to analyze the source code. We have to probably make checkbacks with the development staff to make sure that the assumptions that we're making, this is how the code works, is of course valid. That is how the code works. And this all means that there's more time. So something that we estimate is it's probably around close to twice as long as the traditional threat model. So in a traditional threat model timeline, usually when we do it, we have something earmarked of about 8 man days. And that involves the yellow circles being meetings with the staff, the client staff, to determine the information gathering processes, to confirm and clarify some assumptions that we've made, and to review any output documentation that we have at the end. That's what we have in a traditional threat model. But with the code level threat model, it can typically stretch to almost pretty much 15 man days. So you do have your information gathering process, and that's very similar, but now you're analyzing actual source code, and you're going to make assumptions, or you're going to come up with ideas of how the code works based on your analysis, and you have to confirm and clarify that as well with the client staff. And you finally create your mitigation maps and your diagrams, and you have a report that is also has to be reviewed. So it does take some more time.
So I guess I would say that comparing the code level threat analysis to our traditional threat model, the information gathering stage is pretty much the same. The use case derivation again is the same. The source code analysis, you're going to spend a couple of days or so to look at the code, to understand the code, not from a threat perspective, but just to understand how the code is flowing, because there might be multiple teams involved, and the interaction between the code might not be very apparent unless you look and understand it from the underlying code review perspective, not from a security but a review perspective. Then you try to come up with some kind of a mitigation map or a threat flow diagram for the major use cases that are there, so you can see where each of these transactions are taking place. And when some additional components are being added to the code, you can kind of say, okay, when you're doing authentication in this piece of code, these are the calls that you should typically make. If you go through that detailed use case with the calls itself inside it that we had shown you, and the advantage of that is a couple of things. One, new users can come and instantly know which components and how to call them, and secondly, you can have standardized modules which are reviewed and developed by experts rather than everyone trying to develop authentication again and again into the various components.
Good point, yes. again, it's something code level threat modeling that identifies threats to the actual code base. It's more detailed than the traditional threat model, but less so than a typical source code review. And the basic steps involved, some are similar to the traditional threat model, but now we also have source code involved, so we have to do analysis of that, and we come up with these artifacts that come out of it, such as the mitigation map and mitigation flow diagrams, and our recommendations stem from that.
So how is this model going to be any better than the traditional threat model to help me do either a penetration test or a threat source code review?
Well, certainly for the standpoint of a source code review, now we've actually had an initial look at the source code. So we know where, we know how the code actually works before we actually look at more details of the source code that would come out from, that would stem from a typical source code review. For penetration testing as well, we now know what kind of objects are involved, so we kind of know how data is flowing between components. It's more of an idea of getting a better understanding of the guts of the application. That from a traditional threat modeling, we know more of a high-level view of how the application works. Now, with this code-level threat modeling, we get a better idea of a little bit of what's underneath before we dig even further if we were to do an actual source code review.
Yeah, I think I would agree, and also if we remember those color-coded diagrams, we can kind of see what type of application security domains are being used and try to perform attacks based on the individual major use cases and actually try to focus our attacks on that, or try to focus our source code review around that to find more logic problems. Because often we also see that developers, you'll find some piece of code that is really, really well written, and then some pieces of code that are not, because it's the developer's pattern of writing that code, and you'll find developer who has written similar code over and over has the same kind of issues inside it.
Right.
So I think that kind of covers everything that we wanted to cover. Are there any questions? Yes.
So what you're talking about is essentially threat modeling plus a little bit of code review to dig a little bit deeper to get under the covers,
Right.
better understanding. So, but if that's going to take 2x the time, that's essentially 2x the cost. So how do you
Yes.
justify that versus just doing a regular threat model in a pen test?
That's an excellent point. So from a regular pen test point of view, let's say you do threat analysis and a pen test, you do find vulnerabilities, but as part of doing this additional step, now you suddenly have an understanding of the actual code itself and the call flows itself. That reduces your time of doing the pen test and reduces the time of doing the source code, actual source code review. So now typically when we go in to do assessments, there are three major components that we are trying to do. We are trying to do threat modeling, pen testing, and source code review in combination, rather than just doing pen test or rather than just doing source code review. The output of it is something like this, the threat model diagram. So what is the advantage of that? Now it's suddenly speaking to developers, it's speaking to architects, it's speaking to security professionals. So if there is a new attack vector that comes out, you can go back to this and you can again map it out. Of course it was there in the traditional one, but now you can actually map it out to the code level, the call level itself. And you can see if it is actually mitigated. From a pen test point of view, now you're, if you look at most of the typical large organizations, they've already done pen tests against their major applications to some level or the other, and they'll hire these companies to come in and do it again. And something that used to be a low risk finding has suddenly moved to a mid level. After all, we have to show that there is value, right? So now, if you do this with some level of source code review, we have noticed that we have started finding a lot more business logic problems, which is an area that is very difficult to identify even if you're doing just a vanilla pen test or doing just the traditional threat model and pen test. The combination of all of this gives you a lot more insight into, the idea is that if I was the developer with the knowledge of the attack vectors and I developed the application, can I be at that stage and look inside the code? Then I'll be able to find a lot of bugs. And how can I get there in the cheapest possible way for the client? And that's why this approach seems to be better. At least we are finding that. Sir.
So I like the positive approach to it, right? You're looking for positive security controls within the baseline. I think that's good, but why wouldn't this just always be the first step of a code review?
It should be. As security compass,
So
we
why do we
always
need a
do
new
that.
name? Why do we need some, I don't think the threat modeling name matches very well to what this is. Right, threat modeling, to me, it has a certain set of activities that's associated with it, and I don't see that squaring very well with what you're proposing. Not that what you're proposing here is bad, just that I would have put it in the code review category as what you do to prioritize the security concerns to get ready for a code review.
I don't have an answer for that. I guess yes, but at the same time, if you notice that when we go to an organization to propose a code review, their first response is, well, we have ounce and 45, why do we need you, right? The second thing is, okay, here is a model that is slightly different, there is an advantage for it. Now, there is still a level of awareness raising that is taking place even with the threat modeling itself. A lot of financial institutions who are typically the leaders in accepting security, at least the way we see it, apart from the government, I'm not talking about them, are still accepting threat model to a certain degree. But other organizations, we don't see them accepting it very readily. We have, in the last few months, come up with this model, and I guess there isn't a direct answer why are we calling it threat model. We are trying to call it code review. That's why we are trying to say it is threat. I forget the name now.
I think you raise a very good point, because this sort of stemmed from the situation where we had a client wanting us to review a separate application, and we had reviewed one before with a threat model, and they wanted a threat model on this other application that ran on the same ran on the same architectural framework as the first application did. So we started to do a threat model, and we realized what we were producing for them certainly wasn't very different at all from what we had produced for the original application. So we started to think about what's something we could produce that provides more value to them, and that's where this all sort of stemmed from. So to call it a threat model, that's, I guess, sort of how it approached. We were traditionally doing a threat model, but it was more based on the code, geared on the code, and we sort of came up with code level threat analysis. But you raise a good point, saying that it's almost a misnomer to just call it a threat model itself, because it does deal with the code level. So you do raise a good point in that sense. I think the naming of it or the description of it is still something that's being tweaked a little bit, but it's just a different approach that stemmed from it. So, yeah.
Threat model has almost 10 years of baggage of what the name means. And I think code level threat analysis actually says a lot more to me than calling it anything related to threat models, just for whatever that's worth.
Steve.
So having done some of these and seen how the process of mapping out the mitigation works, do you think that would be something that could be ported into the development lifecycle from the developer and the business analyst point of view as a step that would help the developers visualize the defenses as they're building the code? Kind of, because one of the things you keep saying is we have to have source code to do this, but how about reversing it and making the mitigation map before writing the code? Do you think that's something that would work, or?
That's a very good point, and that is something that we would obviously like to drive towards. One of the other reasons why we started even getting a lot into this is we went into this organization, the same organization he's talking about, and we did training for them on attack vectors, and then did on code review as well, and threat analysis. But when we went back to their environment a year later, yes, they were trying to implement it. There's different levels of reception in the head and actually going back and implementing it. So there are a lot of factors into it. One, we sat down with them and realized that if they actually had a push from top down and they had a security in the software development life cycle itself, then they can definitely do this. So right now we're sitting down with them and doing exactly what you suggested. That is, okay, let's look at your software development lifecycle. Let's look at integrating this into your lifecycle itself. And so we're going in and not only helping them develop this and bring it to a certain level so that it can be extended by architects and developers, but also try to attach, kind of coding standards or guidelines, if you will, so that when we go back to that those categories, we are saying, okay, authentication. Okay, whenever I'm doing authentication, I want to use my bank authentication class, no matter what, right? So where is a new developer going to find that? If we give him a really thick volume, he's not going to read it, right? He doesn't have the time to read it. He's typically, I need it done yesterday. So we have to come up with this streamlined process that is pushed from top down, as well as some level of documentation, and the education needs to go all the way back to the business analyst and kind of questionnaires around that have you thought about this? Are you thinking about when you're asking us to develop this application and turn around and have it on Monday, are you thinking about these major risks? And if you are you willing to take the risk? You sign it off, and then there needs to be specific demarcation of who is taking the risk. And you'll find this in a lot of organizations, there is none. Okay. I hate to stop asking questions. The next speaker needs to be on, but if you would like to ask us, we'll be standing outside, or catch us. We'll be going on a pub crawl, I'm sure, tonight.
Thanks, guys. Feedback form in your door at the back. Still not turn them in downstairs for registration day. Next schedule, I think, is Stephen Lenny, Steve Field, and
Thank you. Thanks for coming, guys.